just as has happened every time you learn a new set of numbers, once you get the hang of how they work, what they mean, you learn how to add, subtract, multiply, and divide. Radicals are no different. Today we're going to talk about multiplying, dividing, and simplifying radicals. But before we get into the nitty-gritty, I want you to have two overarching ideas to keep in mind as we're working. The first is it is almost always easiest to simplify first, since those make the numbers, the radicals, easier to work with in general, and it also always your answers have to be expressed in simplest radical form. So you can save yourself quite a bit of complex computation and factoring and whatnot if you do this first. The second big idea I want you to think of is that for the most part, radicals behave a lot like variables. Because if you think about it, irrational numbers we sort of don't know exactly what they are. So if you get stuck, think about what you would do if you were if you were doing that with a variable. Okay, I'm trying to think of a good example for each of these. Okay, so if I have 3 root 2 times 4 root 18, right away I should notice that 18 has a perfect square factor of 9. So this is 3 root 2. Root 18 is 9 times 2, so the 3 comes out, making this 12 root 2. So that's like what I'm talking about, simplify up front. Secondly, radicals behave a lot like variables. If I said 3a times 12a, we'd know that equals 36a squared. Just like that, it's 36 times root 2 squared, or 36 times, maybe easier to think about, 36 times root 2 squared. And here's another thing to remember. If I take the square root of 2 squared, it equals 2, because rooting 2 and squaring it undoes the root. So this equals 36 times 2, or 72. Don't worry, these are going to get easier as you practice. But this whole notion, so if I say root 3 times root 3, that equals 3. If I say root 5 times root 5, that equals 5. Let's go on to the next slide. If I have a problem that says root 2 times root 5, well, if I said a times b, it would just be ab. Similarly, root 2 times root 5 is root 2 times 5, or root 10. We already know that from simplifying. This is going the opposite direction of that. If I say root 3 times root 12, we should note that 12 is really 2 root 3, and so 1 times 2 is 2, and root 3 times root 3 is 3. That gives me 6. In this situation, you could also see that it would be the same as root 36, which equals 6. There are a lot of ways to go about these problems, but primarily you really just have to be clear in your head about what it is you are trying to do. If I say 4 root 2 times 3 root 3, I multiply the coefficients and I multiply the radicals. then I always make sure to see if it's in simplest radical form, which it is. So basically, just like with variables, you're multiplying the coefficients, and then you're multiplying the radicals, and then always make sure your answers are in simplest radical form. This goes throughout the chapter. So that's how multiplication works. You're multiplying the coefficients. Well, first you want to simplify, then you're multiplying the coefficients, you're multiplying the radicals, and you're checking to see if they're in simplest radical form. That's why you want to simplify up front. Otherwise, you're going to have big numbers under the radical to talking about dividing. Well, actually, if I have a problem that says root 3/7, oops, root 3/7 times root 14 over 27, and those don't have any common factors, so we can't simplify up front. This is really equal to the same thing as 3 times 14 over root down here. So we're going to cancel. And that gives me root 2 over 9, which is root 2 over root 9, and that equals root 2 over 3. So basically what you want to do is put it all under one fraction and one radical sign, cancel out the common factors, then divide them in the end, and make sure that you've got simplest radical form. Like if I say, for example, if I said, let's say I did a problem, let's see, and I ended up with root 5/7. Well, that equals root 5 over root 7. And the problem with that is that 7 isn't a perfect square, so I can't do that. And I'm not allowed to divide by irrational numbers. So as I was saying before, we know that root 3 times root 3 is equal to 3. So if I want root 7 to equal a rational number, I can multiply it by root 7. And if I do that to the bottom, I have to do it to the top. So now that equals root 5 times root 7 is root 35. And root 7 times root 7 is 7. This is called rationalizing the denominator. In other words, you're not done if your denominator has a radical in it. You have to multiply by whatever it takes to make that a rational. Thinking again about how to simplify up front, this has its own kind of thing. So another general idea is that radicals can cancel with radicals. Oops, that's not what I wanted to do. Radicals can cancel with radicals, and constants can cancel with constants. So, say if a problem started out like this, I can simplify 3 and 9. 9 goes in here 3 times. And I can simplify this. Root 3 goes into root 24, root 8 times. So at this step of the problem, I have 3 over root 8. Now, root 8 has a perfect square factor. So that's the same as 3 over 2 root 2. And as I said before, we can't have a radical in our denominator, so I have to multiply by root 2. and that gives me 3 root 2 over 2 times 1 is 2, and root 2 times root 2 is 2. So the final answer to this is 3 root 2 over 4. Simplify up front. Constants cancel constants. Radicals cancel radicals. The more you can deal with those up front, the easier life is going to be. So let's see about this. Okay, I'm just going to keep doing examples. These are not necessarily, they're just examples that are in the book. You might say, well, there's nothing to do here, but you should notice. Can't have a radical in the denominator. To get rid of root 5, I multiply it by root 5. If I do it to the bottom, I do it to the top. 3 times root 5 is 3 root 5. And root 5 times root 5 is 5. Get used to that. That's something that I hope you understand. Root 5 times root 5 is root 25. And that equals 5. It's a shortcut just to go straight to here. Okay. Root 7/8. First divide it. Root 7, root 8. Simplify up front. Root 7 over 2 root 2. Get rid of the radical. Times root 2. That gives me root 7 times root 2 is root 14. And 2 root 2 times 1 root 2 is 2 times 2, or 4. That equals root 14 over 4. And finally, one that looks like this. This is a little different. 3 and 3, root 3 and 3/7 times root 2 and 1/3. Well, whenever we're working with fractions, we have to first turn them into improper. So this gives me root 24 over 7. And I'm going to multiply it in under one big radical with this one, which is 7 over 3. These are all radicals, so they cancel with each other. That gives me root 8. And as I know, root 8 is 2 root 2. In case you've forgotten, that is because it's root 4 times root 2. And root 4 is 2. So it's 2 root 2.